In this video, we're going to cover Objective 1.2, find the distance between 2 points in the coordinate plane using the distance formula. So, in this case, we're given 2 points, and I'm going to think of the first point here as point number 1, and the second point they gave me as point number 2, and in that case, I can think of the x-coordinate of 0 to be the x-coordinate of point number 1, and the 7 here will be the y-coordinate of point number 1. And then over here on this point, -6 is the x-coordinate of point number 2, and -1 is the y-coordinate of point number 2. So now we know what we've got here to substitute into the distance formula. I like to draw the structure of the distance formula first so that I make fewer mistakes. So the distance formula is comprised of a great big square root symbol, and within it we have the sum of the squared differences. Differences between the x's and differences between the y's. So, we'll first substitute in the x-coordinate of point number 2 here, which is -6. And from that we'll subtract the x-coordinate of point number 1, which is 0. And then over here we'll substitute in the y-coordinate of point number 2. And from that we'll subtract the y-coordinate of point number 1. So now we have all of our substitutions. We just simplify carefully. So we've got -6 minus 0 is -6. That will get squared. And next we have -1 minus 7, which is -8, and that will get squared. So, using order of operations, we worked within the parentheses first. Now we're going to evaluate exponents. So we've got -6 times -6, which is positive 36. Next we have -8 times -8, which is positive 64. And simplifying still, we take the sum now. 36 plus 64 is 100. And so we understand the distance is the square root of 100, which is 10. So to see what we have done here is, if you just make a 10-second sketch of these 2 points, we've got point number 1 was at 0, 7. I'll pretend that's about up here. And point number 2 was at -6, -1. I'll say that's about there. Oops. And the distance between them we have determined is 10 units. And that is what we have learned with the distance formula. In this video, we'll once again find the distance between 2 points in the coordinate plane with the distance formula. So, when they give you the 2 points, it's helpful to think of one of them as point number 1, the other one as point number 2, in which case you have the x-coordinate of point number 1 and the y-coordinate of point number 1, and you have the x-coordinate of point number 2 and the y-coordinate of point number 2, and you have everything you need to substitute into the formula. Distance formula. If you write the structure first, there. Now we'll substitute in the values. We are substituting in the x-coordinate of the second point first, so that's -6. Then we'll substitute in the x-coordinate of point number 1, which is 5. And then we'll go to the next grouping and substitute in the y-coordinate of point number 2, and then the y-coordinate of point number 1. Now we just have to simplify carefully using correct order of operations. Let's work inside the grouping symbols. We'll have -6 minus 5, -11, and that will get squared. And then we have -9 minus -7. So -9 minus -7 is -9 plus 7. So we have -2, which will get squared. -11 squared is +121. -2 squared is +4. So we know the distance to be the square root of 125. Now you know how to simplify that radical number, because that radicand, 125, has within it a perfect square factor. So let us factor the radicand. Well, I know it's divisible by 5 because it ends in 5. So let's see, 5 to 125, that'd be times 25. Now I know the square root of 25 is 5, so I know that 25 could come out. Square root of 25 is 5, leaving the lonely 5 under the radical. But say we just continued factoring. We took the radicand, we got 5 times 25. 5 is prime, I'll circle it. 25 can only be factored into 5 times 5. So using the factoring to primes method, I get the square root of 5 times 5 times 5. And here I've got a pair of 5s. 5 times 5 is 5 squared. That comes out as a 5. So either way, whether you like to factor all the way to primes or you like to catch a perfect square factor as early as you can and take it out, either way, you get a distance of 5 square roots of 5 for the distance between those 2 points. So what we have found is that if one point is at 5, -7, let's estimate down here, and the other point is at -6, -9, further down, the distance between them is 5 square roots of 5.